Hello everyone, I am Jung Le from National Institute of Informatics, Japan. It's my pleasure to present our work, Open Forensics, large-scale challenging dataset for multi-phase forgery detection and segmentation in the wild. Face forgery, also called deepfake, aims to swap identity of two persons or manipulate facial properties of persons. Deepfake detection is challenging because deepfake techniques evolve every day. The problem becomes extremely challenging if we mix forged and real faces together or natural scenes. Can you point out which faces manipulated in the slide? Conventional deepfake detection methods do not have the ability of localizing the faces. They only work on classification tags, and the performance is heavily dependent on a face detection method. To overcome these issues, in this work, we address new tasks of multi-phase forgery detections and segmentation in the wild, meaning that we can train end-to-end deep networks as well as control the performance by ourselves. To achieve the goals, our main contributions are to present a novel large-scale dataset and provide a benchmark suite. In this work, we propose to use GAN models to generate infinite human identities for multi-phase swapping. Using this GAN-based framework, we build a large-scale dataset. First, we extract faces in an image and check their manipulation possibility. We then synthesize new faces by GAN models and swap into original faces. We also employ a forgery classifier and reject all synthesized face cannot spoof our employed network. Finally, we annotate the faces for multiple texts. We constructed a large-scale dataset with 115,000 images and more than 330,000 faces. Our Open Forensics dataset supports both deepfake and general fakes related text because of rich annotations. You can see our annotation in the bottom right. We also simulate real-world context by various data augmentation, so our dataset can be utilized to evaluate the robustness of models. We conducted extensive user studies with four popular deepfake datasets: Face Forensics Plus, the FTC Celeb Deepfake, and Deeper Forensics. Our experiment shows that the visual quality of images in the Open Forensic dataset is highly evaluated by most participants. It means that our dataset is judged to be the most realistic with the highest mean opinion score. We also evaluate human performance in recognizing the face as real or fake. Participants have the most trouble distinguishing between the real and fake images in our dataset. We also investigate the correlation between visual properties and human ability to recognize forged faces. The ability to recognize forged faces depends on image realism, resulting in an increased phone surveillance rate as realism improves. The graph shows that a large number of participants misclassified forged faces in the Open Forensics dataset as real faces. Next, we asked the participants to identify the number of forged faces in each image. Our result shows that the detection accuracy was the highest when there were no forged faces in the image and tended to drop as the number of forged faces increased. This can be explained that when there are many faces in the image, participants tend to less carefully check each face and guess that all the faces are real. That explains why the accuracy is high when all faces are real, while it is significantly reduced when forged faces exist. This highlights the challenge of our Open Forensic dataset. We conducted a competitive benchmark for multi-phase forgery detection and segmentation. To this end, we train and evaluate recent instance detection and segmentation methods in various scenarios. We evaluate both performance on standard images and robustness on augmented images for two tags, detection and segmentation. The experiments show that even recent instance detection and segmentation methods still cannot effectively solve real-world challenges. So, multi-phase forgery detection and segmentation in the wild is still far from being solved, leaving large room for improvement. Thank you so much for your attention. Please visit our website for the dataset and code.